Okay, now we're going to get into problems in this section where the problems are given to us in a table format. So this section is called numerical integration. So instead of giving you an equation, the numbers are given in a table format. So this first problem here says this is the population of a certain town over a 20-year period. And we're going to assume that this, whatever this equation may be, it's going to be a differentiable function. And here are 5 data points that they give us. Okay, this first question here is going back to something from the way beginning. I want you to use this table to come up with an approximation for the derivative, or the rate of change. And we want to be able to explain that answer. So if I want to come up with the best estimate for what happens at, this is your time, at time 12, I should use the 2 closest points, which would be at 10 and 13. So the best estimate for what happens at time 12 would be, remember, the derivative is just the slope. So these are the only numbers that I have. So I'm just going to find the slope between these 2 points. So y2 minus y1 over x2 minus x1. Or f of b minus f of a over b minus a. And this is going to give me this. Okay, and let's think about our units here. This number on the top is the number of people. This is your year. So this is people per year. So what this number represents is this is what's happening at t equals 12 years. So this is saying at 12 years, population, this is a positive number, this is our slope, is increasing at a rate of 196.333 people per year. Okay, anytime they ask for explanations, you want to make sure that you have units in your explanation. So you need to put years with that number 12. This needs to go with that number. Okay. Now, the next thing is, it says use the data from the table to do what's called a trapezoidal approximation. So this is a new piece here. A trapezoidal approximation is basically a Riemann sum, but instead of using rectangles, we're going to be using trapezoids. So let's think about this data table here. I'm going to make a rough plot of these points. So let's say 0, 2500 is here. 4, again, rough sketch. Let's say this is 10, this is 13, and 20 is all the way over here. So rough plot of these points. So what we're going to be doing is, instead of using left and right hand rectangles, we're going to come up with basically area using trapezoids. So this would be my first trapezoid. This would be my second trapezoid. This would be my third trapezoid. This is going to be my fourth trapezoid. So basically what's asking you to do is I want the average population of the town over this 20-year period. So as soon as you see that word average, you got to be thinking this. Remember, 1 over b minus a. My bounds, I'm going to do it over the entire 20-year period, is going to be from 0 to 20. And I want the average of the population. The population is the function y of t dt. So this is my setup. If I had this equation, that I would just take the antiderivative and plug in the bounds, etc. Since I don't actually have an equation here, what this problem is asking us to do is we need to be able to find the area underneath the curve. But since I don't have an equation, I'm going to do a trapezoidal approximation for this value. So this 1 over 20 is still out in front. That just represents the idea of average. And all I'm going to do is find the area of these 4 trapezoids. So remember, area of a trapezoid is 1/2. Your height of the first trapezoid is 4. These are your 2 bases. If you look at my table, those y values are 2500 plus 2724. Plus, that's your first one. I'm going to do the same thing for the second one. Area of the trapezoid is still 1/2. The height of this trapezoid is 6. These 2 bases are 2724 and 3108. There's my second trapezoid. Do the same thing for the next one. 1/2. This height is 3. My 2 bases are 3108 plus 3697. That's this trapezoid. And then we got one last one, which is going to be 1/2. This height is 7. And then I have 3697 plus 4283 is the last base. So this is an approximation for this area underneath the graph, which is an approximation for that definite integral right there. So whatever all of this ends up being, it's actually, if you punch it out, this is what we get. So it's saying on average, over that 24-year time period, there was on average 3,304 people. And that seems to make sense with these numbers that I'm given.